welcome back to Proportions. Let's get started with a key idea. So some key ideas when we're talking about proportions, remember that we use ratios to compare two quantities. When we know that the ratio that compares two things, we can use that ratio to find an equal amount. And we must always use two equal ratios. And we have two equal ratios, we call that a proportion. Let's take a look at example A. So here we are at example A, and it says a tree casts a shadow that is 15 feet long. At the same time, a man who is 6 feet tall casts a shadow that is 9 feet long. How tall is the tree? Now notice I've got my proportion set up there with a box to the side, so I'm going to be filling in that information. Now when putting together a proportion, it doesn't matter which item goes where in my proportion, as long as I make sure that I keep all of the pieces in the right place in regards to the other pieces. So for example, the shadow is across from the shadow and the height is across from the height. So let's take a look at our example here. So it says a tree casts a shadow that is 15 feet long. So that's important information. I'm going to highlight that the shadow is 15 feet long of the tree. At the same time, a man, so the man is going to be different than the tree, a man who is 6 feet tall, so it tells us that he is 6 feet tall and he is the man, cast a shadow that is 9 feet long. So again, I'm going to highlight shadow and 9 feet because that is important information. So I've gone through and I'm trying to figure out how tall the tree is, and I pulled out a lot of information out of my problem. So I know I'm going to be comparing two things. I'm going to be comparing height and shadow. So I'm going to put the height on the top and the shadow on the bottom. It doesn't matter whether shadow's on top or height is on top. Just remember that if you select height on top, then you need to make sure the heights are all the way on the top. And if you select shadow on top, then shadow would be all the way on the top. Now, the two things that we're comparing are the man and the tree. So again, I want to make sure that I have the man on one side of my proportion and the tree on the other. It doesn't matter which is which. So I'm going to put the man on the left-hand side and I'm going to put the tree on the right-hand side. You don't have to write these things all out, but it might be important information for you to have down. So first off, I have to figure out the height of the man. Do I know the height of the man? I do. It told me that it is 6 feet tall, so I'm going to put a 6 underneath the height of the man. Then it tells me that he casts his shadow 9 feet long. So I know under shadow and under the man, I'm going to have 9. Now let's take a look at the tree. And the only information I have about the tree is that it casts a shadow 15 feet long. So I know under shadow, I'm going to have 15 for the tree. I don't know how tall the tree is. So when I don't know something, I'm going to use a variable. In this case, I'm going to use x. So now that I've set up my proportion, I need to solve it because I didn't actually figure out how tall the tree is yet. I've just set up a proportion in order to help me figure out how tall the tree is. So the first thing I need to do when solving proportions is to cross multiply. So I'm going to cross multiply 9 times x and 6 times 15. 9 times x is 9x. We're still solving a proportion, so it should still have an equal sign in the middle. And then 6 times 15 is 90, so I'm going to write that down. Now I've got a one-step equation, which is quite easy to solve. I'm going to draw a line down from my equal sign. Then I have to do whatever I do to one side of the equation, I have to do to the other. The opposite of multiplication is division, so I'm going to divide both sides by 9. 9 divided by 9 is 1, or 1x, and 90 divided by 9 is 10. So x equals 10. However, this is a word problem, so I need a word answer. And since we're talking about height and we've been talking about feet the whole time, x equals 10 feet. So this tells me that the tree is 10 feet tall. Now let's take a look at example B. Here we are at example B. Example B says, on a map, the town hall is 2 1/4 inches away from the baseball stadium. The map scale uses a scale where it is 1 inch is equal to 12 miles. What is the actual distance between the town hall and the stadium? So the first thing I need to do is go through my problem and find that important information and highlight it. So the town hall is 2 1/4 inches away. That's important information, so I want to make sure that I go ahead and highlight that. Then I need to go through and read that the scale is 1 inch to 12 miles. So that's, again, an important information that it's talking about the scale. And then I'm trying to figure out the actual distance between the town hall and the stadium. So now I need to figure out the two things that I'm comparing. And I'm not comparing the town hall and the baseball stadium. Those are not the two things I'm comparing. What I'm comparing is the distance on a map compared to the distance in real life. So the two things that I'm comparing are actually inches to miles. So again, it doesn't matter whether I put inches on top or miles on top, just so long as I am consistent with what I choose. Now I need to fill in the two things that I am comparing. So I'm comparing the scale of the map to the actual distance in real life. So now that I've got inches and miles set up in one place, scale and actual set up in another, now I need to fill them in. So I have a scale that tells me that it goes from 1 inch to 12 miles. So I'm going to fill that in. So I know that 1 inch is equal to 12 miles on my scale. Now I need to take a look at the actual. And I don't actually know the distance for how far the stadium is from the town hall, but I do know that on the map it's 2 1/4 inches. Now I can't really put 2 1/4 inches in my calculator, so I'm going to have to turn that to a decimal, but luckily I know that 1/4 is 0.25, so my scale on the map is 2.25 inches. Now I don't know the actual distance, so I'm going to label that as x. Again, you could use any variable. Doesn't matter. I like x, so that's the one that I chose. So now that we've got our proportion all set up, we need to cross multiply to solve. So 12 times 2.25 and 1 times x. 1 times x is just x. 12 times 2.5 is 27. So x equals 27. And good news, I don't actually have to do any solving of an equation here. Since I end up with 1x, I don't have any coefficient to go with, so I just know that I have x is equal to 27, but this is a word problem, so I need a word answer, so it is 27 miles, since that is the actual distance, not the distance on the map. Now let's take a look at example C. Here we are at example C, and it says Rawa surveys students during RAISE and finds that 35% of the students say math is their favorite subject. If 112 students like math, how many were in the survey? So the first thing that we need to do is go through and find important information in this problem. So looking at the problem, it says Rawa surveys students during RAISE and finds that 35%, so 35% is an important number there, of students say they like math. So 35% of students say they like math. If 112 students like math, so again, that's important information, 112 students like math, how many were in this survey? So we only picked up 2 numbers out of our problem, but we're going to have to figure out how to find a third so that we can make a proportion, because remember we need 3 numbers and then an x, and right now we only have 2. But let's go ahead and set up a proportion with what we do know. So we're going to be looking at the number of students that like math versus the total number of students in this survey. So now that we know we're going to be comparing math and the total, we need to set up our 2 sides of our proportion. So the 2 things that we're going to be comparing are the actual number of students and the percentage of those students in a survey. So we're going to set up one side as the actual number of students and on the other side the percentage of survey. So now let's fill in what we know. We know that 35% of students say math. So 35% is part of our survey. Now, how many actual students is that? In this case, it says 112 students. So 112 students is the actual number of students that like math according to this survey. So now we're out of information in our problem, but we still need to fill in the 2 boxes that we don't have. So what we do know is how many students were in the survey is what we're looking for. We're looking for the actual number of students in the survey. So that's going to be our x. So now we're just down to filling in that last box. Well, since we know that we have 35% of students say math, we know that 35% is out of a total of 100%, because every time that you have a percentage, it's out of 100%. So 35% out of 100% gives us our 4th number to our proportion. Now that we've set up our proportion, we're ready to solve. So we're going to do some cross multiplication. We've got x times 35 and 112 times 100. X times 35 is 35x, and 112 times 100 is 11,200. So now I've got a 1-step equation. I know how to solve those. I'm going to draw a wall down from my equal sign. I'm going to divide both sides by 35. 35 divided by 35 is going to cancel each other out, or it's going to give me 1, or 1x. 11,200 divided by 35 is equal to 320. But again, this is a word problem, so I'm going to need a word answer. And I've got 320. In this case, I was looking for students. So 320 students is my final answer. Now let's take a look at a table in example D. Example D says this chart shows Malika's expenses. She works at Target and makes $276 after taxes. How much money does she spend on entertainment each month? So down here in our table, we've got Malika's expenses. It says 32% for savings, 17% for clothing, 19% for entertainment, 29% for gas for her car, and 3% of miscellaneous items, things like Taco Bell that she might be going out to eat. So now we need to look at our table and find the information that we need. So the problem is asking us how much does she spend on entertainment. So the only thing that we really care about in this table right here is this entertainment at 19%. So now we need to set up a proportion using that information. So it says she works at Target and makes $276 after taxes, and we're trying to figure out the amount she spends on entertainment. So we're going to set up our proportion. We don't have our fancy boxes here, but we're not usually going to have our fancy boxes. So it's going to be up to us to make our proportion the way that we need to. So let's draw two lines to set up our proportion. And now let's take a look at the information that we have. We know that she makes a total of $276. So I'm going to put that total down here on the left-hand side. Again, it doesn't matter which side or where you put things where, as long as you're consistent. So $276 is the total amount of money. I need to know how much money she spends on entertainment, and I don't know that. So that's going to be X. So I've got my money all on the left-hand side. I've got the amount that she spends on top for entertainment and the total amount on the bottom, but I don't know how much she spends for entertainment, so that's my X. Now let's take a look at the percentages that I have in my table. So entertainment is 19%, so that's going to be the other side of my proportion. Now the question is, does that go on the top or the bottom? Well, the 19% is not the total percentage. That's not ever a total percent of anything if 19% is the total. So that's going to be on top because that's going to be talking about the money that she's going to be spending. She spends 19%. So now I need a number for the bottom, and I'm looking for a total. And since I'm talking about percentage, my total percent is going to be 100%. So now that I've set up my proportion, I can cross multiply. So I can do 276 times 19 and x times 100. X times 100 is going to be 100x. 19 times 276 is 5,244. So I'm going to write that down as the other side of my equation. Now I've got a one-step equation, so I need to solve that. I'm going to draw a wall down from my equal sign, divide both sides by 100. 100 divided by 100 is 1, or 1x. 5,244 divided by 100 is 52.44. But again, this is a word problem, so we need a word answer. So we're actually talking about $52.44. Now let's take a look at example E. Example E says there are 252 boys in the 8th grade at Robinson. For every 3 boys, there are 4 girls. Which proportion can be used to find the number of girls? So I'm only looking for the proportion that I can be using to find the number of girls. And it says at the top, how many correct ways could I set up this proportion? So I want you to try this for yourself. I want you to see how many different types of proportions you can set up to solve this problem. There's going to be more than one way to set up a proportion, so I want you to try and see how many different ways you can set up a proportion to solve this problem now. So I want you to pause the video, see how many different ways you can come up with, then press play again to see how many there are. How did you do? Were you able to find all 8 different ways a proportion can be set up? So there are 8 different ways to solve this proportion. You can set it up as long as you have boys and girls across from each other, on top of each other, as long as they're staying on the same side as each other or on the same top and bottom as each other, then you're going to have a correct proportion. If you didn't get all 8 ways, make sure that you copy down yours so it looks like mine. That brings us to the end of these notes. If you like these notes, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.